Good morning, everyone. I am Ramya Prabhu from Data Science branch. Today, we are here to present our PBL topic on Canteen Automation System. My team members are Kavya, Chaitra, and Trupti. Contents, introduction, objectives, design, system architecture design, mobile app functionality, integration with NGOs, technology stack, and conclusion. So, introduction. Canteens often rely on manual processes for ordering, billing, and inventory, which are time consuming and error prone. Long queues and delays during peak hours affect customer satisfaction and overall efficiency. Traditional systems lack personalization and do not adapt to customer preferences or demand patterns. Machine learning enables smart recommendation, demand forecasting, and efficient resource management. The automated system enhances user experience, reduces waste, and improves service speed and accuracy. So, now objectives. Smart order recommendation uses customer preferences and past orders to suggest food items they are likely to enjoy. Then, dynamic menu prediction predicts which items will be popular to adjust the menu accordingly. Automated queue management reduces wait time by organizing and managing customer queues automatically. Speech or chatbot ordering system allows customer to place orders using voice command or chat, making the process easier and faster. Customer sentiment analysis analyzes customer feedback and reviews to understand the satisfaction and improve services. Payment and billing automation handles billing and payment automatically, reduces errors and stop. So next will be continued by Trupti.
Good morning everyone. I am Trupti from Data Science branch. Today I am explaining about design, user interface. User interface means it is an app or a touch screen. Why it is used means customers use it to view the menu, get recommendation, place orders and payment. Order management. It is a software that receives customer orders and sends them to kitchen automatically. Billing system automatically calculates the bill when an order is placed. Inventory management system tracks and available ingredients and stock levels. Machine learning model food recommendation suggests the food items based on customer history and preferences. Machine learning model demand prediction predicts how much food or which dishes will be in high demand. Machine learning model inventory prediction predicts when stock will run out based on a sales patterns. Machine learning model customers feedback analysis means it reads and understands customer reviews automatically. Dynamic pricing adjusts food pricing based on popularity or a time. Database system stores all data customers, orders, menu, inventory, feedback. Next slide will be continued by Chaitra.
Good morning all. I am Chaitra. I am going to tell system architecture diagram. How do we architect this app? So first we will provide an app for the customer with a mobile app named Kisok and will recommend it the system will recommend it the item whichever it provided in the canteen. Order management system will give a order list for the customers, then billing system in the kitchen. Overall, the items are ordered. It will give the total bill to the customer through they can pay by UPI or a cash. Then database have orders, payment and inventories. Inventory management system is it will track the stocks available in the kitchen. Then inventory prediction ML it predicts before when the customer is already in the canteen whether what the customer wanted to be ordered by seeing the previous orders. Then admin data board is nothing but we'll give a chat board where the customer can also speak to the chat board and text. Mobile app functionality. App our PBL project runs on an app application where we are the donors and receivers are the customers. We'll provide customers our food provided in our kitchen. Then it requests and receives the recommended food in the kitchen. The next slide is followed by Kavya.
Hello everyone, I'm Kavya and my topic is integration with NGOs. By collaborating with local NGOs and shelters, the app facilitates the redistribution process. Means the local NGOs are a part of the system, helping redistribute the excess food to undeserved communities. NGOs can easily access the list of available food, making it seamless for them to claim and distribute food to those in need, thus creating a network of support. They can easily view and access the available food list. They can claim food and help to distribute it promptly. It creates a support network and reduces food wastage while helping the needy. Next is technology stack. And in this technology stack, for the front end, we use Flutter, React.js, HTML, CSS, and for the back end, Python, Flask, and REST APIs. And for the machine learning, we use TensorFlow, Skitlearn, and Pandas. And for the database, we used MLSQL, MongoDB, and Redis. For cloud and hosting, we used AWS and Google Cloud. And for the DevOps part, we used Docker and GitHub Actions. For the payment mode, we used Stripe, Razorpay, and PayPal. Conclusion. The canteen automation system using machine learning transforms traditional food services operation into a smart, efficient, and customer friendly experience. By integrating technologies like mobile apps, self service kiosks, cloud based services, and ML driven recommendation engines, the system streamlines the entire process from ordering to payment to delivery. Machine learning enhances the system by predicting the custom preferences, recommending popular dishes, and optimizing inventory management based on real time data. And the further part will be continued and second review.
From here, the second review is start. The content is design and implementation. User interface. We design a mobile app kiosk for easy ordering and recommendation. We provide a ordering system for the customer. Order management handles customers order and sends to kitchenware. It is directly sent to the kitchen. The orders are directly sent to the kitchen. Billing system. Automate bill generates and supports digital payment, where here the bills are generated automatically and given the total inventory management tracks stocks and predicts demand, where here the stocks are predicted before and sent to the orders. In this, we use an ML model, which is KNN, which recommends food based on similar user choices. Here, the similar user choices is nothing but it predicts that the orders that the customers want before, where in predicting the previous orders. Then notification system, it's order the orders the orders that are there in the kitchen. It notifies the customer whatever the available food in the kitchen. NGO integration, we are tied up with some NGOs where the remaining foods are sent to the NGO scheme. The next slide is followed by Trupti.
Now I am explaining KNN algorithm, collect data. Data helps your system understand different customer habits. For example, what kind of food they prefer. Uh, Example like veg or non-veg. Next, pre-processed data. Computers understand numbers better than words. For example, veg is equals to 0, non-veg equals to 1. Choose K. The number you choose affects the accuracy of your recommendation. Where K equals to 3, then compare with the 3 similar taste or behaviors. Identify with a similar taste or a behaviors. Identify for an advice. Make prediction. The final step where your system gives a useful result or recommends a food item or classifies the new customer. Further part will be continued by Ramya.
So my part is implementation, front end. So my part is implementation, front end. Tech used is Flutter or React Native. Purpose to build a mobile or web interface for user and admins. Backend, tech used is Python or Node.js. It handles logic for order, billing, inventory management. Database used is Firebase or MySQL to store user data, orders, and stock. ML integration. Here we use K nearest neighbor algorithm recommends food to user by analyzing order similarity. Next, let me walk you through how our website or app works. Front end, the part users see. We are building interface using Flutter or React Native, which works both well on phones and browser. There are two main components: customer login view, where customers sign in, see food option, and place order, and admin dashboard, where admins can handle everything like inventory, order, stock management, etc. Then backend. Backend is the brain behind the scene. It's like the middleman between what we click and the actual result. It handles taking your order, updating stock, getting food recommendation from machine learning algorithm. Then machine learning algorithm. Here we use a technique called K nearest neighbor, which it checks what other users order and suggests food you might like. It's like how YouTube recommend videos, we recommend food. Then NGO module for donation. If there's leftover food, the system connects with NGOs so nothing goes to waste. Then database. It is like the storage room. We use Firebase or MySQL. This includes user accounts, order, and inventory. Next will be continued by Kavya.
It is deployed in Firebase or AWS for real-time access. What it means is the application is deployed on Firebase or AWS called Amazon Web Services, and the purpose is to ensure real-time access to data and services from anywhere, allowing users and admin to interact with the system seamlessly. And next is NGO model. Lists access food and connects with NGOs. It connects with the people, lists the excess food from the canteen or donors, connects with NGOs, enabling them to view available food and request or to claim them, and it reduces the food waste and support people in need through efficient food redistribution. Next is notification. It sends the real-time alerts to users and admins, and the main purpose is to send the real-time alerts to the users when new food is listed or claimed, and for the and admins for systems updates or action taken. And the benefit of this is to keep all the stakeholders informed and responsive, enhancing timely coordination. Next is the overview of app design overview. And in this, we can log in through the login system. We have login system. We can log in through as a student, staff, or admin. And next is home page, where the list of food is displayed. And next is order history. It shows the history of our order. And next is analytics, which is the most popular food and which is sold out today with the highest rate. And next is excess food management. We see, and in this excess food management, we can see the data of NGO models where we can donate the excess food. And next is token system. And in this token system, uh, it helps us to do not wait in a long time for a long while in a queue. So it helps us to save our time. And next is notification. We get the real time access of data during the during the token system, or which is the popular dish among the particular season. And next is payment mode. We can pay through the UPI or cash or credit debit card. Next, the further part will be continued in the third review. Unmute ಮಾಡು. Unmute ಮಾಡಲೇ.
This is overall the website we have created. So first, we have given a three logins to it, which is student, staff, and admin. Student logins are the customers who come to a canteen. So here, this is our website where we have a food menu, then orders. Today's special, whatever is there in our kitchen, this is how we provide them. So that is burger, veggies, veg burger, and pizza. So whatever the student is ordered, it directly go to the cart and gives the total bill. He can give a payment mode through cash, UPI, or card. Now the order is placed and it directly goes to the kitchen. Next, we have a staff login. Here the staff can Here the staff can also order the required menu. These are all the items provided in our kitchen. Total payment modes. This is our admin login now, where this is private only for the owners. Here we can see overall whatever the orders are placed today and the orders pending, then total revenue, then NGO donation. We can donate to NGOs to this. So quantity is whatever the food is remaining and items. Donation added successfully. This is overall the website we have created. Thank you.